Okay, let's have the solution to problem 55. This is the second space thrust. Calculate the reaction components and member forces for the space thrust shown below. Summarize your answers in alphabetical order for the members and write in the last part the reaction components. Squares A, B, C, D, and E, F, G, H are concentric. Side AB is 3 meters while side EF is 5 meters. The space thrust is 3 meters high with a vertical downward load of 60 kilonewtons at D, acting at joint D. So all base supports have vertical Y components at E, F, G, and H. Show first that the space thrust is determinate and stable. So first, for the reaction components, 4 vertical reaction components plus 1, 2, 3, 4. So that makes it 8. Then for the bars, 4 outer, 4 at the top, and 2, 4, 6, 8, so 16. So R is 8 reaction components, joints 4 below, then 4 above, so 8, then bar 16. The criterion is R plus bars must be equal to 3J. So 8 plus 16 is equal to 3 times 8, 24 equals 24. Therefore, this space thrust is stable and determinate. So having checked that it is stable and determinate, we can now proceed by first finding zero force members if we can. So let's look at the details. So if we begin at joint A, we have 4 members, then AE, AF, and AB lie on a single plane, inclined plane, and this is a unique member. Therefore, stress in AD is 0. Distance DH, by the way, is square root of 1 square along X, 3 square along Y, then along Z is also 1. So X, positive X direction, Y direction upward, then Z direction forward. So it is also equal to square root of 11 meters, distance DH, which is also equal to distance CG, distance BF, and distance AE. While distance CH is square root of 4 square along X, 3 square along Y, and 1 square along Z, so square root of 26. It is also equal to distance BG, DE, and AF. So that's it. So again, the stress in AD is 0 at A by some special rules that when all forces lie on a single plane, the one that is not lying on that plane is 0. Then if we proceed to joint C, again we have CD, CH, and CG to lie on a single plane, and BC or BC not on the plane, therefore stress in BC is 0 at C. So we begin by summing up forces along X at joint D. So I will not include AD because it is 0. So SCD going to the right, then minus SDE times 1 over square root of 26. Distance DE is square root of 26 minus SDH times 1 over square root of 11. Then it is equal to 0. Equation 1, summation forces Y at D equals 0. Downward positive, so only 2 members are downward here, DE and DH. CD is horizontal on the top, so 0 SCD, then plus SDE times 3 over square root of 26 because the space thrust is 3 meters high. then plus SDH times 3 over square root of 11. Then there is a load there which is downward equal to 60 kilonewtons. So plus 60 because downward is positive equals 0, so equals negative 60. So equation 2. Then finally, summation forces along Z at D equals 0. So forward is positive. Again, CD has no component, so 0 as CD. Then minus SDE times 4. Z component of distance is 4 over square root of 26. Then plus SDH forward times 1 over square root of 11 equals 0. So equation 3, solving these three equations, 1, 2, and 3 simultaneously gives us the following results. So SCD is negative 20 kilonewtons, SDE is negative 20.4 kilonewtons, so they are compression, and SDH is negative 53.03 kilonewtons. So after at D, we proceed to C. Summation forces X equals 0. So this is our guide. I will not color BC because it is a 0 force member, so that we just ignore that. So SCG times 1 over square root of 11, then minus SCH times 4 over square root of 26, then minus CD. CD is negative 20, so minus negative 20, so that's positive 20 equals 0, so equals negative 20. Equation 4. Then at C, summation forces along Y equals 0, downward positive, so only CG and CH are involved here. So SCG times 3 over square root of 11 plus SCH times 3 over square root of 26. Then no more because CD is horizontal, BC is 0, equals 0. So solving equations 4 and 5 simultaneously gives us SCG equals negative 13.27, which is compression, and SCH is 20.4 kilonewtons tension. Then we proceed to joint B. At C, let's check summation forces Z if it is 0. So SCG, BC is 0, so SCG is negative 13.26 in the positive direction. Then times Z component of distance 1 over distance square root of 11 plus SCH, which is 20.4 times 1 over square root of 26. Then computing, summation forces Z equals 0. So that means our answers here are correct because we check joint C, summation forces Z is 0. So we proceed to joint B. Next. So at joint B, summation forces X equals 0. So we have SBF times 1. These are the forces involved except BC, which is 0. So SBF times 1 over square root of 11. Then plus SBG times 1 over square root of 26. Then minus AB, SAB. Then minus 40 equals 0. So minus 40 equals 0 equals positive 40. Call that equation 6. Summation forces Y at B equals 0. Downward as positive. So SBF is downward, SBG is downward. Then the rest horizontal. So SBF times 3 over square root of 11 plus SBG times 3 over square root of 26. Then SAB has no Y component, so plus 0 SAB equals 0. Equation 7. And summation forces along Z equals 0. So SBF is negative because this is the positive direction for Z. So negative SBF times 1 over square root of 11, or negative 1 over square root of 11, plus SBG times 4 over square root of 26. Then that's it. SAB has no z component, so plus 0 SAB equals 0. So equation 8. Solving this 3, 6, 7, and 8, equation 6, 7, and 8 simultaneously gives us the following result. SBF 0, SBG is also 0, and SAB is negative 40. So these results are obvious from the special rule. That is, if two forces, or because BC is 0 and we have two forces BF and FG, BG 0, then the other two forces will only be 0 if they are not collinear. But because they are collinear, that's why they are equal. So that's why AB is negative 40, and we have a force of negative 40 also. So it's obvious from that results. Then we proceed to joint A. At A, summation forces X equals 0. So let's put the forces as our guide, except AD, which is 0. So SAF times 4 over square root of 26. Then minus SAE times 1 over square root of 11 plus SAB, which is negative 40, equals 0, so equals 40. Equation 9. And summation forces Y equals 0, downward positive at A. So SAF downward times 3 over square root of 26 plus SAE downward times 3 over square root of 11. Then since there's no more downward force, equals 0. Equation 10, solving equations 9 and 10 simultaneously gives us SAF equals 40.79 and SAE equals negative 26.53 kilonewtons. So that's it. Then we proceed to joint D. At A, let's check summation forces along Z if it is 0. So AF is in the negative direction, so negative 40.79 times 1 over square root of 26. Then AE is also in the negative direction, but it's negative, so minus negative 26.53 times 1 over square root of 11. And no more. So compute that. That's almost 0. So therefore, it's okay. Then we proceed to joint E. Summation forces X equals 0. So let's have the forces as our guide. So SEF plus SAE, which is negative 26.53 times 1 over square root of 11, plus SDE, which is from the preceding slide, it was negative 20.4 times 1 over square root of 26, then equals 0. So we can now solve SEF. Stress in EF is positive 12 kilonewtons. So we cannot perform, we can solve the vertical reaction at E, which is denoted YE. Summation forces Y equals 0, upward positive. So let's assume that the vertical reaction at E is upward, or pointing our eyes. So YE, AE is upward, and DE is also upward. So YE plus negative 26.53 times 3 over square root of 11, then plus DE, which is negative 20.4 times 3 over square root of 26, then equals 0. So from there, we can solve YE. It is equal to 36 kilonewtons. So it is positive, so it is upward. Then we cannot solve ZE and EH because there are two unknowns if we sum up forces along Z. So instead, we proceed to joint F. Summation forces X equals 0. To solve for this reaction here, XF, let's assume it is rightward. So XF equals EF, which is 12, plus EF, no? This one, 12 plus AF. AF is 40.79 times XX, component distance is 4, divided by distance square root of 26. And BF is 0, so that's all. So from there, we can solve XF, and XF is rightward, 44 kilonewtons. Then actually, if you compute XH by the entire system, XH plus 44 equals 40, so XH should be 4 rightward, but 4 leftward. But we will not do that. We will just solve that later by considering joint H later. So summation forces Y, upward force positive. So let's assume again that the vertical reaction at F is pointing our eyes, so upward, and there's only one force that is upward also, AF. So YF plus AF, which is 40.79 times 3 over square root of 26 equals 0. So YF is negative. This is negative, so that means YF is downward. So 24 kilonewtons downward. So 36 here upward, 24 here downward. Then we cannot sum up forces along Z because there are two unknowns, G sub F and this force in FG. So instead, we go back to the whole system. Let's solve for G. Let's solve for G sub E this time because we have found XF, summation moment about YG. YG is the axis through our eyes, so by right thumb rule, positive moment would be like that. It's counterclockwise. So forces involved are G sub E, which is unknown. Let's assume that G sub E is positive going forward. Then XP and 40 kilonewtons. The rest, G sub F passes through G, XH passes through G, and the rest of the reactions are vertical, so parallel to YG, as well as the 60 kilonewtons G parallel. So the forces involved again are G sub E, XP, XF, which is rightward, and 40. So by right thumb rule, G sub E times 5 plus 40 times 4, then because XF is rightward, so equals 44 times 5, or minus 44 times 5 equals 0. So from there, we can solve G sub E. G sub E is equal to 12 kilonewtons, so it is in the forward direction, positive. So we can go back to E and sum up forces along Z so that we can solve for the force in EH. So similarly, summation forces along Z, considering the whole system, if G sub E is 12 kilonewtons forward, then G sub F is 12 kilonewtons backward. So that's why we have 12 kilonewtons backward for G sub F. So at E, summation forces along Z equals 0 to solve for EH. So SEH plus S, this is SAE times, or plus GE, which is 12, SEH plus GE, which is 12, plus negative 26.53, this is SAE times 1 over square root of 11, plus SDE. SDE is negative 20.4 times 4 over square root of 26 equals 0. So DE is negative 20.4 from the preceding slide. So solving for SEH, SEH is equal to 12 kilonewtons tension. So everything is found at E. We can now go back to F, summation forces along Z. equals 0 to solve for SFG. So SFG forward, then plus SEF, then G sub F is backward 12. So SEF is 40.79 times 1 over square root of 26, then equals 12 or minus 12 equals 0. So SFG is equal to 4 kilonewtons tension. So also everything is found at F. So we now proceed to joint G. So we proceed to joint G. Summation forces X equals 0. So since everything is going to the left, let's consider going to the left as positive. So remember that BG is 0, so SEG is found in the preceding slides, and SFG is also found. So summation forces X equals 0, leftward positive, SGH plus SCG. SCG was negative 13.27 times 1 over square root of 11, then no more equals 0. So SGH is equal to 4 kilonewtons tension. Then let's solve for the vertical reaction at G. Summation forces Y, upward positive, assuming YG is positive. So YG, only CG is involved. YG plus negative 13.27 times 3 over square root of 11. Remember, the height of the truss is 3 equals 0. So YG is 12 kilonewtons upward. Remember, YE is 36 upward. YF is 24 kilonewtons downward. Then YG is 12 kilonewtons upward again. Then let's check, because everything is found, let's check if summation forces along Z is 0 at G. So because going forward is positive, SFG is negative 4 or positive 4, but it is in the negative direction, so negative of 4, then minus SCG, which is negative, so minus negative 13.27 times 1 over square root of 11. Z component of distance is 1 over distance square root of 11. So that's only the case. So summation forces along Z is almost 0. So that means it is balanced. Then we proceed to joint H. At H, summation forces X equals 0. Let's assume XH is rightward. So let's assume XH is rightward. So XH, those are the forces involved. XH plus GH, which is 4, this is it, plus CH times 4 over square root of 26. CH is 20.4 times component of distance 4 over square root of 26, plus DH, which is negative 53.07 times 1 over square root of 11 equals 0. So XH is equal to negative 4, so that means XH is 4 kilonewtons leftward. So that's why 4 kilonewtons leftward plus 40 kilonewtons leftward is 44 kilonewtons leftward, and XF is 44 kilonewtons rightward. So it balances considering the entire system. Then summation forces Y at H equals 0, upward positive. So let's assume that the vertical reaction at H is upward, and upward forces are CH and DH. So YH plus CH, this is CH, 20.4 times 3 over square root of 26, plus DH, negative 53.07 times 3 over square root of 11 equals 0. So YH is 36 kilonewtons. Then let's check summation forces along Z at joint H if it is 0. So EH is 12, but it is in the negative direction, so negative 12, plus CH, which is minus CH in the negative direction, so minus 20.4, that is CH Z component of distance 1 over distance square root of 26. Then minus dH, which is negative 53.07 times 1 over square root of 11. So that's all. And evaluate that, that's almost 0. So that means it is balanced along Z. So far, all our answers are correct, and they are verified by these static equations. Then let's check, because we have checked along X, considering the entire system. So 4 to the left plus 40 to the left, 44 to the left equals 44xf to the right. Then along Z, we already solved this. This is 12 forward and this is 12 backward. So it is along Y, which is left. So summation forces Y along Y equals 36 at E, negative 24 at F, then 12 at G, then at H, 36. Then because there is a downward load at D, which is 60, so minus 60. So summing up forces Y gives us a result of 0. So that's okay. So we have already found the forces as well as the component reactions. And we now summarize the answers in alphabetical order. So these are the results. SAB negative 40, SAD 0, SAE negative 26.53, SAF 40.79 kilonewtons, SBC 0, SBF 0, SBG 0, SCD negative 20, SCG negative 13.26, stress in CH for 20.4 kilonewtons, stress in DE negative 20.4 kilonewtons, stress in DH negative 53.07 kilonewtons, stress in EF 12 kilonewtons, stress in EH also 12 kilonewtons, stress in FG 4 kilonewtons, stress in GH 4 kilonewtons. Then for the vertical reactions, XF 44 rightward, XH 4 kilonewtons leftward, YE 36 upward, YF 24 downward kilonewtons, YG 12 kilonewtons upward, and YH 36 kilonewtons upward. So that's all. Z sub E is 12 kilonewtons forward, and G sub F is 12 kilonewtons backward. So that's all for this problem. I hope that you can also analyze space thrust by your own.